Learning and Memory, Your Brain's Personal Storage Drama by Nikki Salas. Have you ever walked into a room and completely forgotten why you went in there? It's like walking into the kitchen when you were hungry, but then you forgot that you were hungry. Or studied for hours and remembered nothing during the test, but then 3 hours after, you remember everything? 'Cause honestly, me too. Welcome to the chaos that is learning and memory. This is where your brain is less like a well-organized library that we think it out to be, and it's more like a squirrel hoarding acorns across 5 different zip codes. First things first, memory is not one single thing. It's essentially a team effort that's split into different domains. First, we have the declarative memory, which are facts, stories, and mental images, such as remembering your Netflix password or remembering capitals of California, which sometimes I think is Sacramento and sometimes I think is LA. But that's another story. And then we have our non-declarative memory. Skills, reflexes, motor skills, all of that is connected to your non-declarative memory. For instance, it's like riding a bike or flinching when someone fake punches you during shadow boxing. Thanks, middle school. But how does this all work? Let's talk about the neurons and your brain cells. The reason this all works is because your neurons and brain cells send electrical messages, and when these two fire together often enough, boom, connection. Or as Hebb put it, neurons that fire together, wire together. Or as I would like to put it, bros who text every day become besties, because that's essentially what it is. It's a bromance between neurons. Now, this wiring together is called long-term potentiation, or LTP for short. When one synapse is strongly stimulated, it becomes more effective at sending signals. And here's another fun fact about LTP. When the synapses are sending such strong signals, sometimes nearby synapses also get stronger. This is what we call heterosynaptic LTP. It's basically like a brain group project where even the slacker in the group sometimes gets an A. And, we don't appreciate that in real life, but we do need all of our synapses to work. But you know what? It's all about calcium, because calcium ions rush into the neuron and it kicks off the changes that make the synapse more sensitive. So essentially, if you have no calcium, then you have no memory. And that's no joke. Then we have our LTD, which is long-term depression. But no, it's not that kind of sad, I promise. It's when synapses weaken over time due to low activity. It's basically like when you forget your 4th grade best friend's last name. Sorry, Ruby something. The more connection is used, the stronger it gets. But if you ignore the connection, the brain hits delete. It thinks it's a waste of space. But let's zoom in more. Like, literally zoom in. And we're going to zoom in on the dendrites, which are the branches of your neurons. Do you see those little mushroom-shaped things? Those are called dendritic spines, and they grow or shrink depending on the activity in your synapses. If you have an active synapse, then the spine grows. Inactive, then it shrinks. And yes, your memories physically change your brain's shape. Mind blown. But let's think about, where does all of this even happen? Well, the answer is everywhere. The brain's memory system is distributed between different parts of the brain. First, we have the hippocampus, which helps you remember places and facts. Then we have the amygdala, which stores emotions. The cerebellum, which handles your motor memory and muscle reflexes. And then we have our prefrontal cortex, which is basically the mental planner. And obviously, we can tell, because it's the mental planner, the prefrontal cortex seems a little more fancy. But here's the kicker. Your memory is not a perfect recording. It's more of a remix than a replay. Every time you recall something, your brain reconstructs it. It's like rebuilding a Lego tower you only half remember while blindfolded, but you're a little more confident than you should be. So yeah, sometimes details may shift, but that's what we need to understand. Your memory is not a rewind and play. It's a different version of what it really was. But now that we really understand everything, let's recap. Our neurons are something that When they fire together, they wire together. And our calcium is basically memory magic food that helps all of this go off. And then we also have to remember that our brain is constantly rewiring itself through learning. And like we say, you learn something new every day. And memory lives everywhere in the brain, not just in one place. And don't worry, forgetting is totally natural, unless it's your Wi-Fi password, because I need that. Next time you forget something, just remember, you're living inside the most powerful and weirdest learning machine on earth, a human. Now give those dendritic spines a workout, get some sleep, and hey, don't stress, you got this. Stay synaptic, my friends.